Welcome. Glad you're here. My name is Jen Lepore, Marketing Team Coordinator at Custom Processing Services. And today we have Technical Sales Engineer KT Brickman, who is returning to the podcast to talk some more about milling. So KT, last time you were here, we focused specifically on jet milling. And for our audience, that episode is available on our YouTube channel as we speak. But today I thought we'd go in a little broader and discuss all the milling services, custom processing services offers, and how we determine which method to use on each product. So let's just start off with some brief definitions of, the types of milling that we do here at CPS. So we'll do a little quick game here. So I'll give you a method, and I just ask if you can just give us a sentence or two about what it does and what it is. So jet milling and micronizing.
So jet milling uses high velocity air, throws the particles around, they collide, they get smaller, getting particle sizes down to like 10 micron top size. CPS is like bread and butter. We've got like 15 different mills of that type.
Awesome. Jaw crushing.
Jaw crushing, this is a mechanical mill, works with coarser feed that like comes in chunks and gets it down to a few inches by down. Normally CPS uses this as a pre-grinding step before we further process it to finer sizes.
Okay. Hammer milling.
Hammer milling uses a mounted rotor, or hammers mounted on a rotor in a milling chamber. The material gets impacted, causing it to break down before it can pass through a screen to exit the mill. Normally, this is getting to like a few hundred to a few thousand microns.
Okay. Let's do universal milling.
Universal milling, universal because it has a few different types of arrangements it can be set up in, depending on the feed type and the particle size you're looking to go to. Still a mechanical mill, and it gets down to like 50 to 200 micron range.
Coarse crushing or pulverizing.
Yeah, so CPS has a coarse crushing system, pulverizing system with several mechanical mills in line. It uses the jaw crusher that we talked about before, so you can go from like really big chunks down to like as fine as like 325 mesh or 44 microns.
Okay, and lastly, wet media milling.
Yeah, so this is the wet processing. So the material needs to be wet or in a liquid, water or a solvent. It passes through a media mill, so the media being small beads. They're getting agitated around, collide with the particles, reduces the particle size, and this is the finest that CPS can go, normally to an average of like 1 micron or smaller.
So thank you for the quick little breakdown there. So since, there are a number of milling options, I'm kind of curious about what factors go into determining which one is right for a particular project. So the two that kind of come to mind for me are material type and end use of application. So let's kind of start there. So if a customer brings us a material for milling, what type of characteristics do you look for right off the bat that provide some clues about milling methods to consider?
Yeah, so the first thing we're going to be looking for is the feed size and the final target size that they're looking to go to. That's going to put us in the general ballpark of what type of equipment we're going to be thinking of, or multiple pieces of equipment to achieve the desired target size. The other thing we're going to be looking at is like the safety data sheet and understanding if the material is hazardous. Does it need like a segregated area? Is it combustible? We'd only be looking at the equipment that can handle combustible materials. But back to like the actual material, like how it breaks down. Is it friable? Is it rubbery? Is there tackiness to it? Is there fat in it that's going to be exposed when the particle size gets reduced? Is there moisture? Is it abrasive? Are there any temperature constraints? Can it get too hot? Can it melt? Is it going to affect the product after it leaves us, but before it gets into the application? So there are several different things we try to look at, and that was only some of them I mentioned. Sometimes as we get more details from the customer, we might have more questions.
Absolutely. So This kind of leads me into my next question for you is, do you think there are any characteristics that automatically exclude a material from being milled? And like, what types are there?
I don't think there's any that necessarily 100% exclude it from CPS processing it, but it would probably make some things like very cost prohibitive. So like rubbery materials I mentioned before, they don't do well with just normal milling. You're normally going to have to introduce nitrogen or cryogenically grinding it. That can get very expensive. And unless the final application can handle that, most of the time that excludes that business. Another thing is combustibility of very coarse chunks that come in. We mentioned like the core system that we have. That was a perfect fit for large pieces coming in that need to get smaller. But if material is combustible, that system's not rated for it. So we could do that really coarse grinding somewhere else, but it's going to be a lot slower, a lot more labor intensive, and that typically prohibits it.
Okay, so, do you think the end use application kind of dictates how the materials are evaluated for milling?
How they're evaluated for milling? Not necessarily. We're going to be looking at the same things no matter what the final application is. Most of the time, we don't even know what the final application is, so we have to approach everything as broadly as we can to help us narrow down the best way to do something.
So, like, along that same line, like, how might the application influence the choice of the milling method?
Yeah, so if we know the application and we know the requirements from the customer, then it'll definitely drive not our evaluation, but the mills that we look at to mill it on. So if you've got a food or you've got a pharmaceutical or a GMP application, we're going to be looking at the equipment in our GMP facility. We don't want to set it up and say, oh, we're going to run this on this technical grade product or product line, and that's not going to work for the end use. Same thing for if you got something that's technical grade, we're going to look at the technical grade equipment and not run it in the GMP facility where it's going to be more expensive.
Yeah, absolutely. So, based off of what you're saying, it sounds like particle size control is a main focus here. And do you think you can kind of explain to me like the significance as it relates to determining the milling choice?
Yeah, so all those mills we mentioned at the beginning, they all go to different particle sizes and they can handle different feed sizes coming in. There are some crossover where there might be more than one type of mill that can achieve the final particle size that you're looking for. But we're really going to look at the final size and what's going to get us there most efficiently.
Okay. So, based off of everything you're saying, what you learn from the material and the application and the target particle size kind of dictates the type of milling method that we would use. So is there ever a time you think when there's more than one method that could be used, and how is the final choice made?
In some cases, there are going to be a couple milling choices that are available. They're both going to get to that particle size that the customer is looking for. But if a customer has experience with past processing or they're making it in line right now and they're just looking for someone to help them out with volume, then we can try to pick the mill that most closely duplicates what they're currently doing or replicates what they've had success with before. Another thing we would look at is what's going to be the most economical option. We want to run the material as quickly as possible and as efficiently as possible. So that way it's priced as economical as possible. And we can get it on and off the equipment and get on to somebody else. So we'd look to run it where we'd have the most success, and it's going to be the fastest pretty much.
That kind of brings up another question based off of what you said. CPS works with customers in a range of different industries. So the needs kind of vary. So how do you think their customized milling solutions are handled?
Yeah, so when we get an inquiry, we're trying to get as much information as possible with the starting feed, the end use, how the material is going to be used. Has there been Has it been processed before? Is there a reference sample? Could we take a look at the reference sample? We can measure that and see, okay, does it have a broader distribution? So we're going to need this type of mill to achieve it or replicate it. Or does it have a narrower distribution where you really need to control that top end? So you need a mill with an internal classifier wheel. So we try to get as much information as possible so we can understand what's been successful before, or if it hasn't been trialed before, or if you want to tweak what you've done before and get something a little bit different. We've got the small scale mills that we trial on. We've got the production size mills where we can run multiple truckloads in a campaign. So we've got a lot of versatility of things we can trial, small and large scale.
Awesome. Well, KT, this has been great talking with you again. And I appreciate you taking the time to kind of sit down with me and go through everything regarding milling. And thank you everyone for watching this month's Custom Processing Toll Manufacturer Minute. If you have any more questions about CPS's milling services, just reach out to our team anytime. Also, be sure to subscribe to the CPS blog to rewatch or catch up with podcast episodes and get the latest news and insights from all of our experts. And we'll catch you next time. Thanks.